A ribbon on my finger reminding me to do stuff. Okay, because we cannot have 0 in the denominator of a fraction, anytime there is a variable in the denominator, we're not sure what that number is. It could be anything, except for something that would cause the denominator to equal 0. So if x is the only thing in the denominator, what can it not equal? 0. X cannot equal 0. So we would write that as a restriction that x cannot equal 0, which means x can equal anything else. It can be a positive number, a negative number, it can be a fraction, it can be a decimal, whatever. But it cannot equal 0 because if it is, then that entire fraction is undefined and it cannot exist. Now, in this denominator, x is not by itself. It's being added to something. X can equal 0 in this case because the denominator will be 2. But we need to figure out what value can x not equal so that this entire denominator does not equal 0. What can x not be? X cannot be negative 2. Very good. Okay? So we've got to look at what is this x being combined with. Because it's not, you can't just say x can't equal 0. Because in this case, 0 plus 2 is 2. We still have a fraction of 1/2. All right, in the next fraction, the entire denominator is 2 times something. What can that something not be? 0. Because it's multiplication, anything multiplied by 0 gives you 0. Okay? So here are 3 different looking fractions. Notice the numerator. I just have a simple 1 right now, but we're going to get a little bit different in a second. Numerator doesn't matter. The numerator can equal 0. It's okay. But I've got to figure out what limitations there are on x, because I don't want to end up with an undefined fraction. Okay?
So we're doing the variables?
Well, ask yourself, do you need a restriction on this x?
No.
Why not? It's in the numerator, and the numerator, it doesn't matter. So there are no restrictions on this variable.
What is it? Any row number?
You wouldn't have to write anything, actually. Because if there's a restriction, we're going to put that semicolon and x cannot equal. If there is no restriction, you just leave that part off. Okay? So here there were no restrictions because there's no variable in the denominator. Now here, I'm going to show you a shortcut. Can anybody tell me real quick, without even solving anything, what that might be? What x cannot equal?
-3.
Well, if x is -3, that's -6 plus 3, that's a -1/3. Okay, so we're all right. Watch this. If I do not want this denominator to work out to equal 0, I'm going to solve this equation for x to figure out what x can't be. You have a question? Or you think you know it? What? Very good. That is correct. All right? Now I want you to look at what do we always do when we're solving a simple equation like this. The first thing we always do is what? Isolate the variable by undoing the addition or subtraction. So the first thing, we're going to do the opposite of this plus or minus, right? And then we're going to divide by the coefficient of x. So x, in this case, cannot equal -3/2. All right? Now, I want you to look at the problem. Let me write this back where it needs to go. I took the opposite sign of 3 because I would have to subtract 3 to get it to the other side, right? And then divide in order to undo the multiplication. Negative 3 over 2. Now let's look at that. What's 2 times negative 3 halves? Negative 3. And what's negative 3 plus 3? 0. Okay? So that is what would make that denominator equal to 0. Therefore, it's our restriction. What would the restriction be on this one without setting up an equation, just looking at it?
Positive 5 over 3.
5 over 3. Positive 5 over 3. X cannot equal 5/3. Okay? Real quickly, remember if there is a letter in the denominator in the numerator, that's okay. We are only restricting variables found in the denominators of fractions at the bottom. How many times does the letter X show up in the denominator of this fraction?
Twice.
Twice. So you have a possibility of 2 different restrictions. Now there's also an X in the numerator. Does that matter? Don't matter. Okay? All right, so let's focus first. This is something times something.
I thought if it's X, don't they all have to be the same thing?
No, they do, but we're going to look at them separately and you'll see why. Okay? Whatever this works out to be in parentheses, if I multiply it times 0, which would be this X, what would it give me? 0. So this first X, since it's all by itself in a multiplication type situation, cannot equal 0. Okay? Because look what happens in the denominator. If both X's are 0, it's 0 times negative 3, which is still 0. Okay? Now, no matter what this first X is, if X is a number that causes this thing in parentheses to equal 0, what's 0 times anything? 0. So in this set of parentheses, what can X not equal? 3. All right, now let's try that out. Because if X is 3 in the denominator, what does that work out to? 3 times 0, which is 0. So if the letter X shows up however many times basically in the denominator, that's how many restrictions you're going to have. Okay?
Wait. Confused about the 3.
Say this is all I had. What can X not equal? 3. Okay, because that's 0, right? Well, if X is 3 and this works out to be 0, even if X is still 3 right here,
0.
3 times 0 is still 0. Okay? All right, let's look at this one. How many X's do I need to restrict? 3. Why not 4?
Because you don't worry about the numerator.
I don't worry about the numerator. Okay? Now, you're going to look at each of those 3 little things independently, without regard to the others. All right? This X by itself, standing alone, cannot equal what? 0. In this first set of parentheses, X minus 5 cannot work out to be 0 because that would be 0 times 2 more numbers, which would give you 0. So what can X also not equal? 5. And in the last set of parentheses, that X cannot be a number that would cause that set of parentheses to equal 0. Negative 1/2. Okay? Because yes, even if all the X's are 0, if only one of them is 0, when you multiply it out, it's undefined.